So just talk us through the Labsphere box here that you've got. You're generating presumably lots of different profiles of light, different colors of light, making up the light that we can see with our naked eye coming out of the top of the box.
That's correct. It's a tunable light source. So it has multiple LED input, and it's characterized over the dynamic range of each LED. So any spectrum can be input into this, for example, an illuminant A or sunlight.
You can basically recreate any light condition at any color profile and check that your sensors are still performing within the parameters in which they're designed.
That's right. A sensor is going to respond differently to the ambient light that's around it. So it's going to respond to incandescent lighting differently than it's going to respond to sunlight. Testing that sensor under those different lighting conditions is important for color balancing, white balancing, flat fielding.
This sensor is used for lots of different environments other than automotive as well, right?
That's right, mobile devices. What's really important today is with the action cameras, and particularly in the automotive, is the wide-angle field of view now. There are fisheye lenses on there that are approaching 240-degree field of view. And to test those, you need to flat field that whole field of view with a uniform Lambertian source. And so that's very difficult to do. And what we've done with this system is allow the user to do that by placing the sensor right through the port. And through that port, it's collecting a very high uniformity luminance field.
Because typically, with a fisheye lens, it's not unusual to see weaknesses around the edge of the lens because you've distorted the image and you're disrupting the flow of photons going through the glass as well as hitting the sensor at its weaker areas around the edge, right?
That's right. You're going to get vignetting. If you're looking at just a flat target, then you're going to get fall off around the edges. Or if you're looking at just a uniform source, your sensor is going to see baffles, it's going to see hot spots in it. You don't see any of that in this type of source.
Right, so it's ideal for testing a sensor against, not just for looking at edge case performance, but also to see that the sensor is performing within parameters as well.
That's right. You can correct for vignetting, color aberrations, flat fielding the pixel, dead pixels. So there's a large assortment of testing that you can do with just a uniform flat field.